All right, here we go, transforming linear functions. So the objective, we're just going to look at transforming linear functions. You've already had a taste of this when we started with some of the GraphMaster stuff. And we're going to look at solving some problems and also sort of wrap our heads around the stretching and compressing in both horizontal and the vertical directions. So horizontal shift of h units. So the input value is changing. So your x is what's changing if it's sliding along the x-axis. That's what you see here, going from the green to the red. So when h is greater than 0, it moves right, and when h is less than 0, it moves left. So if you did +3, it moves over +3. Vertical shift, k units, the output value changes, so you're moving up or down depending on that input. So the output value, that's the y, so this is changing that vertical shift of y units. We'll move it up a corresponding number of y units. So going from here, so for instance, if it was y equals x is the line in blue, then maybe it's y equals x plus 3. We're going up 3 units. So we're changing that y direction by 3 units. It just moves the whole thing up 3. Reflection across the y-axis or about the y-axis. So essentially you're making your x coordinates negative. If we had point 3, 3, for instance, when we reflected about the y, we're really changing that x coordinate, and that would make that corresponding point -3, 3. Right, so the y stays the same, but the x changes. So your input changes. Reflection across the x, you could probably guess based on the last one, but if we take a look, we'll go with that same point, 3, 3. This time, if we're doing a reflection across the x-axis, that 3 stays the same in the x direction, but it's that y that changes. So the corresponding point when you reflect it across the x-axis is 3, -3. That should be pretty straightforward for you guys. So, an example of translating and reflecting functions. So here's where it's easy to see the picture and see what happens, but when you start throwing in all the language and symbols, I think that's where sometimes things get a little bit confusing. So let g of x be the indicated transformation of f of x. Write the rule for g of x. F of x is equal to x minus 2. Now if we do a horizontal translation, 3 units, translating f of x 3 units right subtracts 3 from each of the input values. So here's where the notation comes in. G of x equals f of x minus 3. So you put in this x minus 3 into your original function anywhere you see an x. That's how I like to think of it. So we're doing an x minus 3. We put that in x minus 3, and then a minus 2 will give us x minus 5, which is the same thing as subtracting 3 from each of those values as it goes in. So the new function, the g of x, is x minus 5. Again, we just take the x minus 2, and we're putting in x minus 3 anywhere we see an x. Hopefully that makes sense. So we're going to translate reflecting functions. So the first thing to do here, we're given f of x from the chart. So all of these points, negative 2, 0, 0, 1, 2, 2, and we're connecting those points. We connect those points, that's the line. Now it says write the rule for g of x once we do this particular thing. So the particular thing that we're going to do, this was a linear function, that's how we knew we could draw a line through that. It says a reflection across the x-axis. If it's reflecting across the x-axis, that means this is going to be flipping down across the x, so that in that horizontal direction. So that means if it was negative 2, 0, that new point, I'm going to go with red on this one, that new point is going to stay the same. At 0, instead of being at 1, it's going to be at negative 1. So maybe we'll do a little table. So at negative 2, it stays 0. At 0, it goes to negative 1. And at 2, it goes to negative 2. So at 2 to negative 2. And we draw a line through those. And that is the reflection across the x-axis. Because remember, it just makes the y values negative. That's how it flips that around. That's a translation across, reflection across the x-axis. Stretches and compressions, change the slope of the linear function. If the line becomes steeper, the function has been stretched vertically or compressed horizontally. If the line becomes flatter, then it's been compressed vertically or stretched horizontally. So these things don't change. Y-intercepts in a horizontal stretch or compression, and the x-intercepts in a vertical stretch or compression. So if you can try to visualize those, if you have some sort of function, you have this line, if there's a horizontal stretch or compression, if it's a compression, it would be pushing this thing towards the y-axis, but it's not going to change this point. So that y-intercept is going to stay the same. Same idea if you're stretching that. So little quiz, see if you can figure out what exactly is going on. So horizontal translation 3 units to the right, what might that look like? Then we have a reflection across the x-axis, a vertical stretch by a factor of 2, and a vertical shift up 4 units. So as you're writing these down, see if you can come up with the solutions. So you can kind of sketch this out. This is what you should have. Given that we had f of x is 3x plus 1. So horizontal translation 3 units to the right. So you can just pause the video on each one of these as you work through it. Some of you may be able to get it right off the bat. If you have trouble with any of these, we'll talk about them in class. Reflection across the x-axis. So that would be the reflection across the x-axis. Think about what that does for you, how that came about. A vertical stretch by a factor of 2. It should make sense. And now we have a vertical shift up 4 units, followed by a horizontal compression of 1/3. See if you come up with those. And we'll go from there. All right, hope you all had fun. See you next time.